Hello, everyone. Welcome to episode 33 of the Day Zero podcast. I'm Spectre, with me is Z, and we're going to jump right into our first topic, which is around Pwn to Own. So, in the last episode, we talked about Pwn to Own, specifically that they'd be allowing remote participation in this year's Pwn to Own Vancouver due to all this coronavirus craziness that's going around. But obviously, over the last week or so, the virus has really blown up in terms of severity, and there's a lot of things getting canceled or getting moved to online only, and that's basically what's happened here. They've moved Pwn to Own Vancouver so that it's remote only. They're not going to be hosting the contest on site at CanSec West. They said the schedule won't change and the results are going to be shared with the conference organizers so that they can share them with attendees, but all the participation is going to be remote, and there's not going to be any actual ZDI staff on site.
Yeah, what I found interesting with this announcement was just that, all the attempts will be made by ZDI researchers out of Austin, Texas. So, fine, but when we were going over the announcement last week, one of the things that was mentioned was that this is basically going to be, if you decide to participate remotely, this is going to be a one-shot. Either your exploit worked or it didn't work. And I'm wondering if that's going to be adjusted at all now. Because everybody's remote, and they don't mention that. I definitely tried finding that out. And as far as I can tell, they really don't give any mention towards that. They do say, of course, they're in communication, but they mentioned they'd be in communication last time, too.
Yeah. I would imagine that they would have to lift that restriction, just because it doesn't seem reasonable.
I would hope so, but
on everyone.
Given the time constraints that you're already under when you're participating, I can kind of understand if they didn't, just because, one researcher might understand what somebody's saying better than another and be able to help more. Just in terms of what the researcher understands in terms of you need to adjust this value. Well, where's that in your payload type thing? Whereas another researcher might be more familiar, and that kind of gives an advantage to those that get the better researcher who's able to help out more. So I could understand if ZDI doesn't, but at the same time,
to be fair, at least with the attempts, I think the contestant would send the payload directly to them just to run it. I think the ZDI people would just be running the exploits. I don't think they'd be tweaking it themselves. I think the researcher would tweak it and resend them a new version kind of thing. I could be wrong. There's probably a lot more details sent to the actual contestants.
That's a fair point. I really don't know. It's just that no adjustments being made definitely seems like if everybody's going to be remote, they'd want to lift that. Otherwise, the results of this will maybe look rather too positive for some companies.
Yeah, it'll definitely be interesting to see how it goes. They do say also that they will have the vendors. Obviously, they won't have them on site, but they have the vendors on the line kind of thing for when the vulnerabilities are, confirmed and stuff like that.
Yeah, which definitely makes sense. I mean, that's a big part of the whole thing is the fact they do give the advisory to the vendor, so...
Yeah, there is going to be a bit less, or a bit more of a communication barrier, I guess, though, between the researchers and the vendors, where they're, not in person physically. But... I don't think it's a huge issue, and I think it's probably worth the trade-off, to do it remotely because of this, all this craziness going on. I think
it's really move. That or canceling it. So of course,
yeah, absolutely. But it's kind of it's an amendment to the last article that they had with new information, so we definitely wanted to bring it up. The next one's a little bit cheerier though. It's from Google announcing their first VRP Prize winner. So last year, they announced a Google Cloud Platform Vulnerability Researcher Prize to promote security research into Google Cloud Platform. And just now, they've just announced the winner for the prize for 2019.
Yeah, well, so there were several winners. They have several prizes that were being given out as part of this.
I think it's up to 6 or something like that. They have a...
Yeah, there's 6 prizes. First prize, though, here's $133,337.
That's for this year, not for last year.
Oh, is that? Yeah, okay, good point.
Yeah, so they did, that's another thing, is that they ended up tripling the prize amount for this year's prize. So this year's prize pool is $313,337, which was no accident, of course. But yeah, that is for this year. I just wanted to quickly point that out. Sorry, you can continue there though.
No, that was all I was really going to go with was just that this was kind of part of their. In other places, they also refer to this as the VRP grants, which seems to be part of a larger program. I'm not exactly sure, but then part of Google Cloud Platform specifically, they want more people looking at that, so they added in basically more money towards it. So for that, obviously they kind of announced at least one of their winning write-ups, which was for Google Cloud
I would pronounce
shell
the winner's
bugs.
name, but I would butcher it. I can guarantee it.
Yeah, well, we can at least say their organization is Offensi, or at least that's where they've published their write-up. And the write-ups, of being one of the winning write-ups here, it's fairly clear, straightforward issues. Actually, the issues are kind of interesting. They do cover 4 bugs. And there's a live overflow video that covers these also, but just kind of give a quick note on what they were here. I mean, with the Google Cloud Platform, one of the features you've got with that is your Google Cloud Shell. Basically like, or at least it can be, you can do other things, but kind of having like a IDE in the cloud. So you can say on a GitHub, you can have a link to opening the Google Cloud Shell or open in Google Cloud, and you'll have this little link that I should probably bring up the correct file. You'll have this link that opens up Google Cloud Shell, and will open up, or it'll clone your Git repository, open up a file if you specify one for that, which ends up in the example case here in a Python file. It'll load up the Python language server. If you're not familiar with kind of the language server idea, it's just trying to move the implementation of like your language meta information. So like an IDE, rather than needing to implement support for every language under the sun, it just needs to support this one common language server protocol that it can then use to get all the syntax highlighting, get error messages, get typing information, get all of that stuff that you might want to query, you might want to have inside the IDE. It queries the language server for that. So that's where the Google Cloud Shell will basically support some syntax highlighting because it will run this Python language server. The interesting thing that was known for this bug was that the Python language server would look for some libraries that wouldn't exist within the home directory. But it would try and load them. Obviously, it would fail, and it would just move on from there. So what you could do is if you cloned a Git repo that would expand into one of the libraries it was looking for, so I'm talking Python libraries, not your shared object libraries, it would go ahead and execute the init of whatever library you had. So you can get code execution as the cloud account that's running, basically exposing all of that user's information, and basically whatever the user had access to, you'd now have access to. The second bug being their custom Cloud Shell image. Again, so by default, it uses a particular, I believe it was a Debian-based Cloud Shell.
Okay, yeah, I see it now. I see it on the browser.
Yeah, Debian 9 stretch Docker image would be kind of the default one that it would use. And from there,
so they just don't like sign it or anything. They just allow you to run any image.
Well, so they do have some protection.
Okay.
When you load a custom shell image, it won't do things like loading your credential information into the Docker instance. So it loads it in Docker. And it won't mount like your credential information. It won't mount a lot of sensitive stuff, but you can specify any Docker image for it to run. It just won't have access to a lot of stuff if you use a custom one.
Okay, fair enough.
But what they found was that while var run Docker sock, which is kind of your default Docker inside of the Docker socket communication to Docker, that's like the default socket location for it. That one would just be like your normal Docker client, and then just tossing it inside of the Docker shell. Fairly standard, but they also would mount Google/host/var run Docker sock. And that was the host, like the Kubernetes host Docker socket, or at least a level outside of what you would have had. It's not entirely clear. It's just, it's the host. I believe they refer to it as just the host Docker socket. So from there, you're able to execute your own Docker commands with higher privileges. So you can basically create a custom image that would create a new Docker container that would mount everything privileged. And I mean, I'm probably butchering these quick explanations as we go through these kind of quickly. It's a good write-up, though. You can give it a look yourself also.
Did you check out Live Overflow's video at all, by the way?
I did not. I meant to do it before we started this, but...
That's okay.
But yes, or did you have something to say?
No, you can go on. I was just going to ask about the other two bugs as well.
Yeah,
if you had information on this.
Yeah, that's where I was going to go into. Third one here with Git clone. Basically, with a Git repo, you can have hooks. So these are like a pre-commit hook, post-commit hook. Just scripts that will run when you perform some action on the repository. Usually that will be used to like pre-commit, you might want to run all your tests, or perhaps you'll only do that like pre-push. Like you'll have it run all your tests, and if the tests pass, then it will actually commit. What you can't do, just kind of with your standard repo, or at least by default, is commit the hook scripts themselves to the repo. But basically what I found is using a bare repository, there is a hooks folder that you can just commit straight to. So then when the Cloud Shell goes and clones the repository, it's able to have a hook that will happen on the cloning. And so you get another script executing just as that root user, as the main user again. And kind of a similar issue. Well, I guess not a similar issue, but at a similar point, the fourth bug is go and get pwned.
I do like that they kind of named that last one.
Yeah, and as you can guess, it takes advantage of go get command, which was actually an undocumented parameter with the Cloud Shell. You can give it a go get parameter, which would cause it to do go get on that repository. And in examining the Cloud Shell Docker image, they found that it had a vulnerable version of Mercurial installed. Just no vulnerability with that, so they were able to create a repository that could go get would end up grabbing and would take advantage of that exploit. Again, that's just kind of the really quick overview of what these issues were. These are all very good write-ups, so you can take a look yourself. I'm going to assume that the Live Overflow video is solid. He actually mentions at the start of it that Live Overflow was able to polish it up a little bit more, so I'd assume they're fine. I mean, I have no reason to think Live Overflow wouldn't do a much better job than we've just done going over them.
Oh yeah, I was gonna say, like, Live Overflow generally does like a really good job on those kinds of videos, so it's definitely worth check. I'd say check that out probably over the write-ups. The write-ups might be more detailed and like code snippets and stuff like that, but I think the Live Overflow video will be probably a bit less dry and more accessible.
I didn't find these to be too dry, really.
Okay,
but I'll say, I mean, some people like videos. I don't. I prefer reading these things, so I always kind of go towards that. But I totally there's a lot of people who like to see the video, so I get that.
It's cool that there's both options out there for people. But like, there were some noteworthy things in the Google posts as well for GCP directly that I thought would be worth bringing up for anybody that's potentially looking at submitting into that. They say that you can make multiple submissions for the prize, and that you can use a free tier of the Google Cloud Platform for research purposes if you don't want to pay for the the higher tiers. Now, as I mentioned earlier, they tripled the prize pool. The prize is pretty crazy. First place gets 133K out of the 300K prize pool. Second place to sixth place also gets prizes that, obviously get reduced as you go down. So the prize amount's pretty crazy. But one thing that is worth noting is I don't think the reports themselves also get a bounty on top of that. So it's more of like a contest thing where only your best submission kind of gets a payout. I don't think you get a payout on top of that for individual bugs you find. At least it didn't seem to indicate that that was the case. So, there is this really high bounty.
Well, so I don't think that's the case actually. So, or I do,
Really?
I
Okay.
believe you do get paid. So I believe this is part of their vulnerability reward program grants specifically, which is a separate thing from the vulnerability rewards that you receive. I know they always just keep referring to VRP, and they just kind of keep that. Where I'm getting the grants from is perhaps it was in the last year announcement. I'm not entirely sure, but I do believe you're still going to get paid for your finding. Like, you're not going to get shafted if you don't get a prize, for example.
Okay. The way the blog post was worded, it almost seemed like because of how heavily they were pushing the prize program that you didn't get paid for the individual bugs. That was my kind of assumption.
It's possible. I mean, that wasn't my understanding. That said, I mean, that's something you'd probably want to look into. They do have kind of a more detailed like rule information
Criteria,
yeah.
Yeah, so I mean that was just like my like guess. I've never participated in like the Google Cloud stuff for like research, so I could be totally wrong there. It's just something that I was thinking of as that was kind of my assumption based on how heavily they were pushing it. But like you said,
I don't know. I've just pulled up their prize, like the official rules here, and it definitely seems really focused on this being the prize for the write-up that you submit.
Yeah.
And not necessarily like I really can't see them pulling support for like your actual bounty if you had a good finding, being like, nope, you just get this prize. Especially
like
since they wouldn't be
requirement.
deciding on these prizes for quite a while after. Assuming you submitted now, you wouldn't find out until, the next January 30th. So
That would really suck for people like relying on income.
yeah, so I really can't see this being limited, or actually, like I can't see this being the same as the payout for the actual bounty. I mean,
Yeah.
Google pays quite well when it comes to it. I can't see them shafting researchers like that.
But I thought it was really cool that they linked out to Live Overflow. That's probably really cool for him. And
Well, it seems like they sponsored the video in general.
oh, really?
Yeah, so I did.
That.
So I did pull up the video and had started watching it, and then something took me away from it. That's why I didn't finish. But I'm pretty sure he mentions like Google has sponsored it. If he didn't, that would have been like the first few seconds of the video. So if I'm completely misremembering, I apologize. But yeah, I do believe they sponsored him to do that video. It wasn't just.
That's pretty cool too. Like that's good for him, man. Like, he's been blowing up over the last like year or two, and it's definitely the quality of his content is definitely worth that, I think. And it's cool to see like an official Google thing, kind of giving him a bit of a shout out. But that being said, I think that pretty much wraps up the Google VRP stuff. We'll move into some tinfoil hat territory. No, I'm just kidding. But our next topic is a little bit crazier. Yeah. So this one's Whisper.
Just before you go into, I am going to say the tinfoil hat stuff. Honestly, I mean, we had some discussion about whether or not we want to use this source. So I've seen a few places mentioning about Whisper and the recent compromise of it. A lot of them don't actually make mention of who the company was that reported this. And
which is really sketchy.
Yeah, like there's definitely like I'm sure the information they're reporting, seems legitimate. The issue seems legitimate, but there's definitely like a very tinfoil hat conspiracy theory feel to a lot of their posts, including this one. But they have some follow-ups to this, which I think get a little bit more sensational. I think we were a little bit questioning whether or not we actually want to cover this or take one of the more mainstream sources, but 12 Security, they're the ones that first put it out there, so they're the ones that we're going to report from.
Yeah, we always try to use like the original source. So basically what this one covers is about Whisper, which is supposed to be an anonymous social media app.
Have you used Whisper before?
I've never used Whisper.
Okay, I haven't either.
I'm just not really big into social media, honestly. So
Yeah, well, and this is kind of like a, off my chest sort of thing. It's supposed to be anonymous. You can post whatever things you wouldn't actually want other people to know about. You can go ahead and post that out there and kind of get it off your chest.
yeah. So this is one post of a 5-part blog series by 12 Security, and it covers a breach as a result of them apparently leaving their production database cluster open for several weeks. I couldn't really see, it didn't seem like they went into too much more detail about that. They just kind of left it a bit vague.
Well, they mentioned that it was Elasticsearch.
Okay.
So, and we cover a number of these every week.
Yep.
And I mean, it's just one of those things. I mean, Elasticsearch defaults, you put that on the network.
Defaults.
Yeah. We've had that discussion. And in this case, they had it out there. So anybody can go ahead and query everything.
Yeah. What they tunnel in on is how heavy the tracking is on some users, on all users. They have geolocation stuff. They have this field related to predator probability, the top feeds of certain members, which they allege is used for blackmail. But, there's some pretty crazy allegations in the blog series, which is why I think a lot of the mainstream media publications kind of distance themselves from them. So it does seem a little bit sketchy. I was initially saying when I was doing my research into getting notes for the podcast that I couldn't find any media posts that actually linked or referenced this security company, and part of the reason for that is the only article I think that referenced them was a Washington Post article.
Yeah, and to be fair,
because it's paywalled, so.
To be fair on that, 12 Security did reach out directly to Washington Post, so Washington Post are the one that actually broke this story.
Yeah, and a lot of the other articles link back to the Washington Post.
Yeah.
So it's kind of funny in how that works. So I'm not saying any of this is bogus information or anything. It just does seem a bit, like you were saying, sensationalized. They have some pretty bold claims in here. They say that there's a special database of military-related blackmail information on thousands of service members. It sounds really far out there. It'd be really stupid of them to have a database like that of blackmail just sitting on a production cluster.
Well, I mean, if they're collecting it though, they're collecting it off of production. I mean, they're not going to connect to. So, I mean, it kind of comes down to how they're pulling the information. If they're having the app kind of detect certain things and then report that back over, then it makes sense that it would hit production. If they're pulling that information out of what they've collected, then it makes less sense.
It feels like they would, you would think common sense would make them do the latter. If you have, a cache of, a bunch of incriminating information to use to blackmail people, you probably want to keep that separate. You don't expect everybody
to be able to know that either, so...
That's true. It just seems kind of weird, I'm not sure if I believe all the claims entirely, but I think it is worth bringing up. Regardless, the breach did happen.
Apparently the numbers are somewhere in over 1 billion records, not users. I think I saw either Washington Post or ZDI or ZDNet.
Yeah, apparently it's used quite a bit, the app. But yeah, I mean, regardless, the breach did happen. They did say they're also talking with U.S. military. I think they said they were talking with the Attorney General and stuff like that, due to the stuff on service members. So it does seem they're definitely serious allegations, and it seems like a serious breach.
Yeah, it seems they don't give a timeline for their disclosure here of kind of what's already happened. And that's kind of it feels like they maybe disclosed this early. I don't know, maybe it's already resolved. I'd hope it is, but I don't know, since they don't give that information, it feels like there's a lot that's still going on around it. Maybe they shouldn't have disclosed this just yet.
Oh yeah, it feels like it's an active, ongoing thing. They even said they're still coordinating with, apparently coordinating with the military and stuff. One thing I found kind of weird too was I think they created an account or something for the research, and they named it legally searching Elasticsearch or something like that. And it seemed really weird that they would keep that legally term in there. when I'm pretty sure that this wouldn't be legal, because I doubt they have the permission of Whisper to carry out these kinds of tests.
No, and I mean, that's the thing. Like, it is technically just exposed on the internet, but we have seen the Computer Fraud and Abuse Act, at least in the US, being applied to searching public information. So, like, just direct access. So this would be that. This would almost certainly fall foul of the CFAA.
Yeah, so I'm not sure why they put that legally part in there. Maybe they did that on purpose because they know it's illegal.
Yeah, although, to be fair, I mean, the odds that this is going to get them prosecuted or anything, insanely low. I mean, we see a ton of researchers that search Elastic, like just expose Elastic database, try and figure out who it belongs to so they can report it. It sounds like that is what they've done. So, I mean, technically speaking, this probably does fall foul of the law in many places. Realistically, it's not going to be enforced. They've handled it, presumably, given, benefit of the doubt here, they've handled it fairly well, responsibly disclosed that they haven't just straight up dumped it or anything. Oh no, I'm trying to find what you're talking about though, because I do remember that being in an image.
I think it was actually in a text snippet. If you just do like a Control F for
I found
legally.
it here in an image actually.
Oh, okay, there you go. I thought it was in a snippet. So yeah, hacking Elasticsearch legally. So yeah, it's kind of weird.
They even highlight it for you.
Yeah, there you go. So yeah, that happened. If you're interested in that kind of stuff, you could check out those blog posts. Just know that it does obviously have like a political spin on it. Ties to the Chinese government and stuff like that.
I did think it was kind of interesting to bring up, though, just because of the kind of secret side of this. Like, this is an application that is supposed to be secret, or it's supposed to provide some sense of privacy for you.
It's supposed to provide anonymity,
and they track a lot of information that I would not be too happy about.
Yeah, it's kind of like false anonymity. Like, you're anonymous from other people on the platform, but you're not anonymous to the people that actually run the platform, which is an issue,
anybody that gets access to the platform.
Or anybody that gets access.
Which, I mean, okay, being I believe they are at least a Chinese company, though, so, I mean, there are some legal requirements around that, too.
Mm-hmm. Yeah.
But, still, I mean, I thought it was worth bringing up just because of that aspect. I mean, it's not a very technical issue, unlike this next one, though, unless you've got something else to mention on this.
No, I was just gonna say, like, I haven't used Whisper, and I'm probably not gonna use it due to this blog post, to be honest. If I was ever gonna consider using it in the future.
If you have something that you don't want people to know, just don't share it.
Yeah, that's good. That's good advice. But yeah, we can definitely move on to some of the more technical stuff. LVI, that's our first headliner this week. Yet another microarchitectural attack. But this one's actually kind of interesting, in my opinion. It's called LVI stands for Load Value Injection, and it primarily targets Intel SGX. Now, you were saying this one apparently has a trailer as well.
Yes, there's a trailer kind of right here on the page.
Do we want to watch the trailer?
I don't think we want to play it, but it's a very movie trailer feeling. Yeah, give it a watch. It's like, we had name vulnerabilities. Now we have vulnerabilities with movie trailers. And I mean,
Next,
they put a bit of effort into it.
Yeah.
I believe it's a trailer for the presentation at I forget which one of the big main researcher conferences. So,
which it'd be funny if that conference got canceled. Like having a teaser trailer for your conference presentation, and then due to all the coronavirus stuff, it's just like, oh, we're not going to be hosting the conference this year. Man, that would suck. Yeah, but one of the things is it targets Intel SGX. I'll be honest, I feel like we talk about Intel SGX in a negative context so much on this podcast, it's ridiculous. I think we've covered like at least 3 or 4 things in the last like month or two.
Yeah, we've definitely covered them a good number of times. I am seeing them as at least having something specific to SGX in episode 30 and episode 11.
Yeah. So, we've seen a lot of these named vulns at the microarchitectural level. This one is a little bit different, though, because a lot of the attacks we've seen before are, based around leaking an unknown secret through like speculative execution or something like that. But this one actually takes the less treaded approach of, can we inject data into a victim's transient execution, or basically force attacker data to be forwarded from microarchitectural buffers. And they say, we are the first to combine meltdown-style data leakage with Spectre-style gadget abuse to create a new type of attack. So that sentence alone kind of summarizes why theirs is a little bit different from what we've seen before, which is part of the reason I really wanted to cover it.
Yeah, and kind of like the gist of it is they do poison the buffer, one of the kind of hidden processor buffers, and then they induce a fault in the victim. And then the attacker's value that was injected then gets effectively executed or speculatively execute from there, which you can then use for like a side channel.
A fault or a microarchitectural assist, I think. A microcode assist.
Microcode assist is the other thing. Basically anything that gets it to follow the path that they've tried to inject into the architecture. As effectively, you can kind of think about it as like injecting. I'm maybe saying this because of one of the other papers we're going to cover, but almost like injecting like the return address that the fault's going to follow. When it gets fault, it's going to return up to, whatever. So you're injecting kind of that value and getting it to speculate down that code execution path.
Yeah. So, I mean, they have a white paper about the issue, and they describe it as basically a 4-phase attack. They have a cool little diagram on the white paper on page 4. But like, I'll do a general overview of it because I thought it was kind of interesting.
I can bring that up here.
Okay,
you said
cool.
Page 4?
Yep, page 4, figure 3, I think. Page 4, figure 3. Yep, that one right there. So actually, you already had that one up, I think. But they have they actually have a more detailed bullet point breakdown of each phase. So the first phase, they initialize the hidden buffer that you were mentioning earlier with the attacker value. In the second phase, the victim tries to fetch the trusted value from the loaded micro-op. But then the attacker will try to trigger that page fault or microcode assist, which will trigger the CPU to transiently compute using that injected value. And then in the third phase, they try to leak values due to that malicious computation. And depending on the gadget code around the load, they can either encode secrets to exfiltrate them or trigger control or data flow redirection. So if the trusted value is like a pointer to code or data, that's how you get that control flow kind of takeover. And then the last phase is like the fix up, where the results and the instructions are discarded. And they note you can even recover some traces of that through a side channel later on. The second phase is like the most critical part of their attack. So I thought it was kind of cool because they use ideas from attacks we've seen before, like Spectre, with the gadget utilization, but fundamentally it is a different attack. One thing that's worth mentioning is one of the proposed mitigations is to include load fences after every load micro-op. But part of the problem with that is the overhead on that is very costly. They say the overhead is a factor of 2 to 19 for introducing a bunch of load fences like that. They did a benchmarking using crypto operations from OpenSSL speed tool. And they found the performance overhead can reach from anywhere from 0.91% to 978%. So
just a bit of a range there. Right?
Just a bit of a range, yeah.
Yeah, I do want to take one thing out of chat really quickly. Neuropoga mentions LVI is supposed to be fixed in the latest Intel CPU, so just buy new CPU. Buy new CPUs. It's good for Intel. Honestly, so I'm not in a position where I'm buying CPUs frequently or in large quantities, but I feel like Intel has just lost so much goodwill over their handling of these issues. And that just comes down if it were just Spectre and Meltdown, fine, like very significant issues. But then we found out that they were keeping several other vulnerabilities kind of hidden from everybody. They made it seem like Spectre and or at least Meltdown was dealt with. Oh, but actually we knew about these other vulnerabilities. We just didn't tell you about it. By the time everybody kind of does buy their new set of CPUs, it's like, oh, actually those are now vulnerable still to this, and we knew about it for the last like year and a half.
Even this one,
and this one, was disclosed in April of last year.
Yeah.
So I don't know. I just feel like they've lost so much goodwill. Like, yeah, it's good for Intel when people are buying the new CPUs. I just feel like there's that trust that's been violated by Intel here. And they've still kind of got a market share, kind of a de facto share just by their position, but I don't know how, like, I wouldn't be too eager to be buying Intel.
Well, part of the thing too is not only has Intel been having to deal with all these issues, which is probably stifling their like innovation on newer technology.
Well, they weren't really innovating before them.
I know they were kind of sitting on their pile of money, which is another thing that I was going to talk about. But not only are they having to deal with these issues, but AMD is also getting a lot better. And because of the design decisions that AMD took, they're not running into these issues. They don't have to, spend a bunch of time trying to go back and fix these, which introduce high performance overhead. So not only is Intel kind of losing that trust and also performance because of these mitigations, but AMD is also getting better. So it's like there's not really much of a reason to buy an Intel over an AMD unless it's like a very specific circumstance. Like the
at the consumer level, I would say AMD's probably your best bet. That said, I think at the server level there is still a bit more for the Xeons than for Epic.
Yeah, but like getting back to this actual issue, it's a cool attack. It builds on some attacks we've seen before and takes a different approach, but the condition to exploit it is very high. That ability to be able to introduce page faults and stuff like that is why this attack is only really that useful against SGX. So it just seems like more and more the statement of just throw SGX out is becoming more and more viable, because we've seen at least 2 or 3 attacks now that hit SGX that you can't really do anything about. Like the last one we covered was the one where the IOMMU is initialized later than the page tables, so you can basically do DMA writes on the page tables. Like there's a few design decisions with SGX that just seem questionable, to the point of it's just not really worth using if you care about securing stuff.
It's a hard problem too. I mean, you're trying to protect the CPU from a malicious operating system that's allowed to execute on the CPU. Like, it's definitely a hard problem.
Yeah, I won't take away from that. It is a hard issue. It's just that SGX has been getting hammered, and this is just another issue that kind of affects that.
Yeah.
But unfortunately,
I'm not trying to defend SGX, just pointing out, like, because as you've mentioned, we've covered SGX a few times. It's not like we're saying we're going to do better.
Yeah. But I mean, as cool as this attack is, it does kind of take away from it that you need such a high level of access to pull it off. Because of that, it's not really as serious as like Spectre and Meltdown were. Because Meltdown, I'm pretty sure you could pull off from JavaScript before that was fixed. So that's definitely not the case here. You need a higher level of access, but it's still cool how they pull it off. So
I love the idea.
Yeah, it's neat.
I mean that's one of the things. Like sometimes the exploits are just done because you can. It's not always about the practical effect. And I mean perhaps in the future something more practical will come out of it, but it's the first step to get people thinking about it too.
Yeah. So our next cool low-level paper is TRRespass, another named vuln. So it's TRR capitalized SPass, which isn't really a new vuln. It's more of a way to hit a fairly old and well-known attack, which is row hammering. So row hammering, for people who don't know, it's essentially forcing a lot of memory accesses on a specified address to try to trigger voltage fluctuations on nearby rows to trigger bit flips.
Yeah, so I'll just touch on that really slightly. One of the big differences here, though, is you pull this off very differently than how you would normally pull off a row hammer attack. because this is basically going after the mitigation that was put in place to prevent row hammer. So with row hammer, most common, target row refresh, TRR. Most common row hammer, you're doing like a double-sided where you kind of hit the row above and the row below where you actually want the bit flip to happen. And you start targeting those with various accessors, just hitting them over and over until you get a bit flip in the row that you're not accessing. That's your row hammer attack, usually done with just the 2, maybe a few more, but generally speaking, you're wanting to limit the number of aggressors you have, or the accessors. Whereas with this, what happened is with TRR, effectively they looked into what the mitigation was. And what they found was that TRR essentially tries to track how many accesses an attacker performs and on which rows, and then will refresh the neighboring rows instead of basically preventing the bit flip from happening by doing a proper refresh on the data instead of letting it get corrupted. So this is one of those cases where once you kind of understand a little bit about the mechanism behind that, it's like, well, it can't track every access. There's a limit to how much data it can know. So with this attack, instead, by using more aggressors, that's how they're able to kind of get around that protection. They have more aggressors accessing more rows, so it can't keep track of it, and it won't know which rows to refresh in time, allowing the bit flip to happen that way.
Yeah, it's on 2 ideas. They basically summarize TRR as a set of 2 components to make it work, and that's the sampler and the inhibitor. So the sampler tracks how many rows are potentially being hammered, and the inhibitor tries to subvert it by forcibly refreshing the memory, like you were saying. And yeah, like you were saying, with the sampler, you can basically just have it so you get around how many rows it can track, and it can only track so many rows at a time. But you can also hit the inhibitor in a very similar way. The DDR protocol is a synchronous protocol, so because of that, it can only refresh so many rows at a time. So you can either hit the sampler so that it can't detect it, or you can hit the inhibitor so that it can't force the refresh, or you can hit both. So yeah, they basically bypass these limitations of the technology to bypass it. And they tested it on a fair amount of anonymous modules, and they found it was possible. So they don't actually give the manufacturer names of the RAM modules or anything like that.
No, but they do mention that they found it in Google Pixel 3, Samsung Galaxy S10.
Yeah,
I don't know what memory modules they use. I don't know who manufactures them, but if you knew that, you would at least know some of it. They also do mention, though, that they only found it in 12 out of the 42 DIMMs they tested. Which, isn't even half of them.
Yeah. I do wonder, they had a list of the phones, and pixels were common among that list. They had the Pixel 1 through the Pixel 4, and they found the Pixel 1 and the Pixel 3 were vulnerable. They could trigger bit flips on them. But I wonder why they weren't able to hit the 2 and the 4. It is kind of interesting that there's, especially the 2, where there's the gap between the 1 and the 3. You would think that 2 would also be hittable if 3 is hittable. But it's kind of interesting to think about how even phones on the same line aren't necessarily consistent with how often you can hit it.
It makes sense. It really just comes down to who manufactured the RAM, it seems. Which unfortunately they don't actually tell us what RAM is vulnerable to this and what RAM isn't. In their one page, they just use module A4, A8, C12. Not actually telling us anything about that.
Yeah. I mean, one thing I think that makes this attack more interesting is it seems a lot more viable to attack from a lower level of privilege than a lot of the other low-level issues we've seen recently.
Oh yeah, this is something that, can have at least a similar impact to Rowhammer, which was useful for things like jailbreaks.
Yeah. So it is difficult to pull off, and they kind of highlight here with TRR, there are module-specific implementations. They kind of clear up a misnomer that a lot of people that talk about TRR talk about it as if it's a single mitigation. They say it's more like a set of mitigations that are enforced by the memory controller. So it's not, exactly what that implementation is will differ between the manufacturers, which is why you see those differences in the results. But this is something I don't think we'll really see going away. And they even note in the paper it'll probably be upwards of a decade before we see mitigations that can effectively counter rowhammer. And that's even if such a mitigation arises. I mean, it's such a... it's almost like a physics issue. It's an issue that's like super hard to solve from a CS standpoint.
Yeah, well, especially because it comes down to how small, like how close together things are that you can have that impact.
And that's not going to change. Like, that's just going to get even more...
things
are just going to get more compact over time.
It's possible that they'll find some better way of isolating or something. But, it's not an easy problem. And it's not something that's just solved at, the CS level.
Yeah. I do have a bit of a question from this. Do you think advanced persistent threat groups, like nation states, are actually using rowhammer attacks in the real world? Especially now that it's been proven that TRR isn't necessarily effective in preventing it. Like, do you think it's actually going to be used from a nation state context?
Well, I mean, again, seeing as how it has been used, just rowhammer itself has been used for jailbreaks. I mean, that's... I don't see why not, I guess is what I'd have to say to that. Obviously, I'm no expert on APT tactics. But my feeling would be, why not? Why wouldn't they be taking advantage of that? It is a fairly simple issue that can, at the very least, you could have some that just tries it. If it doesn't work, and they move on to another exploit.
Yeah, I guess it's not really noisy at the consumer level. Like, you're not going to see, visible effects on, the phone, for example, if somebody's doing a rowhammer attack on it, I don't think. Yeah. Or maybe it
is reasonably silent.
Yeah. So that's why I was kind of thinking about that. Especially with TRR, a lot of people, I think, thought that TRR kind of killed them entirely. But now that, it's been proven that it hasn't been, maybe we'll see, a rise in those types of attacks. I don't know about that. It's just something I'm kind of theorizing about.
I don't know how often we really hear, though, about exactly what an APT's doing, so... Yeah, I mean, I wouldn't hold out hope to hear.
Yeah. But we can definitely move into some vulnerabilities. Our first one is... not only our first one for the episode, but it's also the first one for this guy in his blog post. So that's pretty neat. And it was an unexpected Google-wide domain check bypass. And he actually found it by accident. He was trying to bypass the domain check in a web app, and he ended up bypassing the URL parser used in a lot of Google products. So he was looking at a API called Henhouse, which basically allows you to generate an API key for you if you press a button for Gmail. And he found this app was basically embedded as an iframe in the documentation.
Yeah, in the Gmail API documentation, that is. Yeah. This is something that Google was using on their applications.
Yeah. So the gears started turning of, can I use this to pull off a CSRF type of attack? Get a victim to click a link, and you can get the API key and then perform actions on their behalf. When he tried it, at first it didn't work because they have a whitelist to make sure the domain is actually a Google domain. You can't just pass any domain you want. But he kept digging into it, and he ended up discovering that they have wildcards that are checked against the domain. And it checks against the .corp.google.com and .c.googlers.com domains. And how they do that check is through regex. Or regex. And when he looked more into exactly how that was working, and it was basically like an obfuscated JS function, so we had to, deobfuscate it and reverse it a little bit.
So before you go there, actually, I mean, odds are this was just a minify thing, so kind of obfuscated. The source actually was out there, though, if you knew where to look. That said, I do want to kind of comment on how the data is being passed back. So the way this iframe worked is you would embed the iframe on your page. And then whatever happens in there, that iframe would use a post message, which is kind of like a internal, well, not internal browser, like browser internals, but it lets you pass a message from one frame to a parent frame or to another frame. Just using the browser. It doesn't make a network request. It's just access to window parent or something like that, post message, and you can send a message over that way. So what happened is when this application would generate the API token, it would send that back to the web page that it was embedded on and be like, yep, and here's the API key that was generated. And doing that, it's not a network request, so you don't have a lot of the usual protections there. But with that, you do have to specify a origin when you make that post message. So the code on screen we've got here does include the domain URL as the target. So there is a little bit of protection there that he's going to look into bypassing. I'll let you kind of get back to that. But I did kind of want to mention how this communication is happening. It is using this post message API. It's not like a network request back. It's not... I'm not sure I'd agree necessarily with calling it like a CSRF style attack. You're just exfiltrating data. It's just a sensitive information disclosure to a third party.
Okay, that's good that you were bringing that up. I was just saying like CSRF and the way that you can get a user to click a link and perform actions on their behalf, right? It's kind of the same like goal, I guess.
Well, I mean, that's kind of like saying though XSS would be the same thing then. Because XSS, you're getting them to click a link in theory. Maybe it's stored. You know, there are other attack vectors with cross-site scripting, but you're then using the XSS and you can make requests to the website and make changes to the website as that active user.
Okay, yeah, fair enough. But yeah, I'm glad you brought that up. That is a really good point. Thank you. But yeah, basically, when he looked more into what it was doing, he found a regex pattern that was used to determine the end of the domain, and commonly how you figure out the end of the domain is looking for special characters, you know, like a slash, a hashtag, a question mark. And the reason you want to do that is because you want to allow for things like get parameters and anchors and stuff like that. So he figured out that he needed to find a magic character that could terminate the domain for the browser, but not for the regex pattern, so that you could kind of append the Google domain on the end of the domain to make it pass that check, but actually go back to the origin domain in the browser. So he basically wrote a quick JS fuzzer and brute forced it, and he found that slash, question mark, hashtag, and a backslash all worked. It terminated the domain in the browser, but not in the library function, which did the validation.
So the backslash was the one that worked in the browser, but didn't work in the regex.
Oh, right, okay. Yeah,
the other three were the ones. So the regex would look for, with the whole regex that it's fairly large.
Yeah, it's a very big pattern.
Fairly large, not something you're easily read. All it does, it parses out the different segments of your URL. Parses out like the protocol, parses out your credentials if you include that, parses out in the fourth place or in the third index is the domain. So it's looking for, you know, the end of, I want to say credentials would have been kind of the thing before that. Either way, goes for your domain. And that's what's comparing kind of for the core.google, like those internal URLs. And it's looking, as Spectre was just saying, for those end characters. And he looked for the one character that the browser would support that they weren't supporting. So,
are you sure it was just the backslash? Because I think he had a list that said that all four of them worked. But maybe
all four of them work in the browser.
Okay, so maybe
but the regex is looking for the slash, the hashtag or pound sign, and the question mark.
Okay, so I see.
So that's what the regex looks for. What he found, though, was specifically, and that mentions, actually here on the one paragraph, so the authority ends with slash, question mark, or pound.
Okay.
And then what he found after doing that was that slash, question mark, pound, and backslash ends the authority.
Yeah.
Or ends the domain.
But like after looking into this and finding this issue in Henhouse, he actually found that this bug was present in many other Google products that use that same library. So that included Cloud Console, the Actions Console, YouTube Studio, and the Google Account Manager. So it ended up being a more serious issue than he originally thought it was. So, you know, he reported it to Google, and he actually ended up getting a $6,000 bounty for it. So, you know, that's pretty cool.
Yeah, fair bounty, good finding. I will mention that he makes mention that, kind of when he's talking about getting started, Yeah, to this day, not sure why, but I did not give up and start reverse engineering the JavaScript to figure out how the whitelist works. I'll say when you run into these security features, just as a general tip for people, assess the security features. Oftentimes there's partial implementations, as we see here, or things get fixed, but they're not fixed completely. It's extremely common for that to happen. So I mean, it's kind of an easy place to look. Obviously, they're already aware of issues in there, so it's kind of harder. But if you're willing to take the time to dig into it, it's a good idea to look into it.
I think part of the reason you see those issues more often than not is because people, when they see that, they just kind of get scared off. They don't want to look into it. So there's less eyes looking at it, right? They see, oh, okay, it's protected against this. Let me look for something else. Instead of actually digging into what the protection is actually doing. I think there's a lot less people doing that, and that's why these issues still kind of exist in there. And even from the developer standpoint, they probably think the same thing. They're probably like, okay, I implemented this protection, it's done, committed.
Move on to something else.
Yeah, I'm gonna start working on this other part of the code base. So yeah, it's definitely a good place to look. But
on a whole, I'll say this is a good write-up. Like, it was an entertaining read. Gives the thought process, the flow into it. It could be a little bit lengthy for what the issue is, but the issue is backslash. Like, the issue is the disconnect between the regex and what the browser actually does. It seems like a lot of issues stem from disconnects between the different components.
Slight discrepancies, yeah. But yeah, it was a very cool write-up, and it was his first one, so definitely.
Yeah, he did a good job with it.
Yeah. We have another issue that's kind of along the same vein with Facebook. Facebook's OAuth, which is their feature that provides that login with Facebook feature you'll see on a lot of websites. They'll let you do that for convenience sake. So after they looked into the Facebook SDK, they found essentially the issue is you can strip out the PHP extension on this one URL XD arbiter. I'm not sure what that.
So let me kind of cover with OAuth is an open protocol, open authentication. It's an authorization protocol. It's basically where you have a website. The website doesn't want to actually do your authentication, doesn't actually want to know your password. So instead, they basically have Facebook do that, and they just confirm with Facebook that you are who you claim to be. And the way that ends up working is Facebook has their URL. This is the connect/ping endpoint. At least this has now been deprecated. But effectively, you'd give somebody that link, and that link would also include information like what your application ID is, your client ID, and it would include a redirect URI. So when you log into Facebook on Facebook's website, so you're giving users a login to Facebook, and it's on Facebook's website. You never see their password. They log in, Facebook then redirects them back over to your redirect URI, and they include a token in that request that then your application takes that token, makes another request to Facebook to actually get more tokens, effectively, your refresh, your actual bearer token, everything that they're actually going to need to use the Facebook API. That's kind of what's happening here is this redirect URI needs to be going to this XD arbiter page. And I'm going to be honest, this write-up I don't feel is as clear. I have a few questions where I'm not quite sure why this happened.
Yeah, it was a bit harder to read for me as well.
But they point out what they notice when they're playing around with that is, of course, usually this redirect URI is going to be validated in some way. Generally, what ends up happening with that is if you just allowed any URL to be placed there, any attacker could craft a link using somebody else's API ID. So with the app ID, what ends up happening is usually Facebook will show like a picture, will show something that makes it look a little bit more legitimate. Obviously, they need to have an app ID with Facebook, things like that. So you'll craft a page, but if you have the redirect going to, some malicious website, they get that token that can be used to then communicate with Facebook. Which obviously is less than ideal. So those redirect URIs are generally fairly heavily validated for an application. So where I'm unclear about what's going on here is what he notices he can take the XC arbiter.php, He can strip the .php from it, and he can add further directories after it. So like xthearbiter / random / directory question v equals 42, adding in that version thing again. So you could do that, and then jump straight into stealing the token from the hash fragment. So I'm assuming what he noticed, it's not mentioned there, is that he could also include a hash, like a URL encoded hash, in that redirect URI, and that could then be used when it did the redirect. It would include that hash in there, so then it would become part of the fragment that isn't actually sent as part of the get URL. That's at least what I'm assuming happened here. Again, he doesn't say that, he just starts talking about stealing the token from a hash fragment. But
yeah,
then,
there's like bits and pieces missing. It's
like it just, he discovers that he can't do path traversal, and then straight into this stealing a token from hash. I don't know. I'm assuming that's what's going on here, because that's the only way it really seems to make sense to me. But then he talks about, so he's gotten the hash, but it's still going to this Facebook URL. It's still this xthearbiter and stuff. So he needed to find a way to get something to happen where that hash could be exfiltrated somehow. And what he found was there was this page proxy in this random JavaScript file that contained code that would strip the hash, take the hash, and it would strip the code in JavaScript, or strip the URL in JavaScript, take the hash and send a post message, same API we just talked about, to the parent frame, with whatever's in that hash. So that's how he's able to kind of exfiltrate it from that. I don't understand, I'm assuming, again, this is some magic with PHP's URL routing, how they can dynamically include some resources in it or something. Effectively, he takes xthearbiter, adds the r/ that JavaScript file as another directory after it.
It's a weird vulnerability. I wish they went a little bit more into why that happens.
Yeah, there's a lot of missing information here.
Yeah,
it seems like that's generally what happened. So I'm assuming that R's for resource and then the resource. So it's saying something like, inject this resource into the page. That's my guess, that there's just a little bit of magic URL parsing so that they can include URLs under certain subdirectories for origin reasons or something like that. I don't actually know, I don't know enough about how this, how page proxy works. He just says, I appended page proxy resource to xthearbiter, and there he goes. It's an interesting issue, in a sense, just by the fact that he was able to do that.
Part of what sucks is that, anybody reading the write-up can't really go through it themselves to see exactly how it works, because obviously this is directly on the Facebook domain. This has already been fixed. So it's not like you can try it yourself to try to understand it. So what's in the write-up is pretty much all you're going to get.
Yeah, and I like this idea of the injection of that little gadget to exfiltrate the hash. I think that's kind of a clever little idea. It's just there's so much else that's confusing around this that I'm unclear about the details.
Yeah. We can talk a little bit about the fixes that Facebook did, though. And Facebook, they didn't really just fix this; they kind of stomped it into the dirt. They doused it in gasoline. They did 4 things. They made it so you can't modify or tamper with the xthearbiter file anymore. It accepts an absolute file path. All the HTTP status redirects are blocked for xthearbiter. The gadget that they used, the 7s, random string.js file, was removed, and they added additional regex validation in some other area. So they did a lot of fixes for this. One thing I thought was really crazy was, did you see the payout amount that Facebook awarded for this bug?
What was it? I probably saw it.
$55,000.
Yeah, well, so this is, it makes sense given the level of authorization you'd be able to get, because once you have this token, you're able to effectively do what you want as the user.
Yeah, just
And you're able to
that's
bypass a
crazy.
lot of security checks because you're basically able to access the Graph API. So you're not going to get the same checks as if you're using the actual UI to like change password, change email. You're not going to need to enter some checks. You can just make some of these changes directly, as an example. But you basically get access to everything that's on the user's account.
Yeah.
So I mean, the
so
amount makes sense. I mean, it's literally an account takeover.
Yeah, but they even mentioned like this is the highest record for a client-side attack takeover. So that amount kind of blew me away. I wasn't expecting it to be that high. But yeah, like you were saying, I mean, I guess it's fair. Like I definitely won't like say that's too high. I don't think there's really too high for a bounty, especially with an impact like that. But that's just wasn't what I was expecting, I guess. That was a lot more than I thought. So that's pretty cool, though, that they got such a high bounty for that. But yeah, like you said, I wish there was a little bit more detail in it because I was kind of struggling to follow along with it.
Well, like it seems to have like fairly good detail. It's just a few places it seems to just kind of skip around. Like I said, the one place there, it just doesn't make sense how they get to a hash. Where is it here? Like, I'll just read the sentence here. I noticed that only one thing was possible to modify, xthearbiter.php v equals 42 to xthearbiter / question v equals 42. So removing the PHP as we had mentioned before. Also possible to add more directory / parameters further, except path traversal. In the first place, stealing the token from a hash fragment is very difficult. It just, like, there's something missing.
Yeah. But anyway, we can move on to our next, exploit. Up next, we have another CSRF, but this one's a bit more interesting because we don't actually know what software or web app the vulnerability was in. It focuses more on the actual exploitation of the bug.
That's why I want to bring this up. This isn't a new attack, but it is something that I feel like isn't quite talked about enough. It's application specific for this particular attack. So JSON CSRFs, generally you kind of have you need some specialized case to actually take advantage of it. One, because sending a JSON body, you need to be able to get like a victim on your own attack page. It's not something like you're doing over GET, for example. In particular, this was a put request, which again, you're not able to craft that from even an attack page. You can't just change you can use HTTP GET, you can do HTTP POST, put, delete, and all the other options, all the other verbs that you could imagine generally aren't going to be allowed to be used from just any random website. You could use it when you're targeting your own domain. There are some cases where you can change the method like that, but generally speaking, it's simply not an option. Unless, going back to the good old days of Flash. I believe Flash used to be able to do the other verbs, at least early on, probably like pre-2014.
Flash.
That said, basically, this covers just a few different tricks to dealing with JSON-based CSRF. But the key one that kind of comes up here, or at least the one that I wanted to focus on, is the method override, and I believe that's kind of their focus. Method override is basically you make another request, so a GET or a POST, and you include a parameter somewhere that tells it to treat this as though it were another method. So you'd include a method override saying, hey, this is actually a put request. I know I'm sending it as a POST, but it's totally a put. This can happen in a few places. It's application specific, so there's no parameter you can try everywhere. In this case, they show an underscore method equals, and then you put in there instead of they use a post request. And it's just one of those little tricks that I've actually seen reasonably frequently in doing assessments, where usually this is part of like some development option that might be getting used during development. Sometimes it is intended to be there in production too, because it lets you get around some of the cross-origin issues, as I was mentioning before, while still maintaining kind of your REST API using all the verbs.
Okay.
It's useful though in cases of, or I will mention underscore overrides one case, underscore method is another parameter I've seen commonly used. And then other places are using it in the header, like X method override, X request override, something like that. Again, any application can do it, but if you know kind of what framework an application is using, you can usually look up and see what the default option would be, or if there is a default that actually does it, and kind of play around. And it's always worth playing around with that, because if you can find it, you can usually find some decent bugs that take advantage of it. If it's not there, it's not there. Like I said, this is application specific, so you do need to be able to leak some information or have some info about how the application's built, which you can discover. But effectively, jumping back to kind of the actual issue here, they're able to craft the CSRF, and what they discovered was, one, that it didn't actually enforce the requirement to send the CSRF token. So just don't send the token, and hey, you're good. Yeah, it won't validate anything.
You would think that they would check, but
you would definitely think they would check, but always test that. That's another thing that's just like, usually it's more like they'll have some error handling that will just be like, okay, ignore it, like
just bail.
It just bails silently and keeps going, which is what I tend to see when it ignores that. I mean, sometimes it'll have just like this general code that's like, if this is present, do the CSRF check. And I will also mention using this sort of method override, really useful for web application firewalls, and useful when applications are checking or performing actions based on the verb that comes in. So say it's performing some check. I believe in this case, it actually does perform some check on every post or on every put. And by using the method override, it'll come in and be seen as one type of request and then later be translated into another. So you can sometimes skip some of those checks. So that's actually, again, another CSRF bypass, can be by sending it as some other request type. Like another fun little thing related to that, you can send it as a get and include a get body that has all the JSON in it, and then do the method override sometimes. I've definitely seen that. So you do a get with a body, which is generally speaking not an actual request, but a lot of applications, you do the method override and it'll still go and read the body. Or maybe not a lot, but I've seen it happen at least.
Okay. But yeah, it's kind of an interesting article, just because even though the bug itself isn't really talked about, and he's intentionally vague about the victim application, it's just one of those articles that kind of reinforces that point of just because there's a mitigation doesn't mean it's always implemented properly. It's kind of like another article to enforce that on top of the one we already talked about, right? With the first exploit we covered with that Google check. So yeah, just another one like that. And it's not often you see articles that focus only on the exploit strategy instead of like the bug. So yeah, it's a little bit weird, but
it's a really useful method though. It's something that, it's one of those things. So like if somebody just asks me for tips, I'm never remembering this. But it is one of those things that is just super useful to know that, this happens, this exists.
Put it in a cheat sheet. But yeah, we'll move on to one of our title topics, which is breaking the competition. So this one's actually about hitting a CTF hosting provider, which they actually have a HackerOne bounty program. It's private. So due to it being a private program, he did have to omit some information about the exact specifics about the pages that were exploited,
or who the provider was.
Oh yeah, or who the provider was. But yeah, this is like one of those fun ones. And he found 5 bugs in this hosting provider.
Yeah, I will mention that the first one's my favorite. This is one that I've done.
Oh, for sure.
This is, if you remember netcat.us, this race condition was the same thing I did against that.
I thought I remembered you talking about an issue that was exactly like this.
Because this is just my favorite little go-to thing when I see a new war game or something pop up. So to be clear, I usually, like, if this is during an actual CTF event, which I have done this during, I'll usually like let the organizers know, one, that's vulnerable, and 2, ask if it's okay if I abuse it once or twice. and I'll let them kind of decide whether or not I can or not. Some of them have been okay. Like they're like, yeah, okay, that's a neat attack. Just go for it, have a little bit of fun, or wait until the very end, points are already decided, and then do it, whatever. But essentially, it's some free points through a race condition. It just comes from kind of the naive way of implementing something like this. You might have a CTF task. You submit the flag. Kind of the naive method of doing your flag submission handler would be, if the flag's wrong, you reject it, of course. If the user's already solved it, you're like, if user's already solved, do a query, whatever to check, reject that if they have. And then if the flag's correct and you've passed those other, you've passed the other checks, so the flag is not wrong and the user hasn't solved it, query their points, add points, or even just do it in your query, select points equals points plus whatever the value is and mark the challenge as solved. The problem is if you make a bunch of requests at the same time, all solving the same challenge, you can have that point thing happen multiple times. So you can end up having like 100 points, 100 points.
Where it's...
Yeah.
Yeah.
So you can keep having the point count incremented, despite the fact that you're only solving one challenge. You're just solving it a bunch of times. This is another one of those attacks that is reasonably prevalent. Whenever you kind of see a situation where the request should only happen once or some limited number of time, they actually make have the same issue a little bit later as one of their last vulnerabilities in this write-up. Nonetheless, race conditions on web applications are kind of a weird attack, but definitely kind of prevalent whenever you see that sort of restriction on the number. Just, give it a try, run 100 requests against it, and you might be surprised by what you're able to do. The rest of the attacks... Not often. It's not often where you have a website that's doing something that's going to be vulnerable, but when it is there, it's not uncommon. Yeah. When you have the website doing that, it's not uncommon for people to implement it without thinking about the race condition aspect. That said, the rest of the issues here I think are a little bit less fun. Denial of service against any user is another issue. Effectively, if you have a CTF where the end date is before the start date, then it just HTTP 500s. You get all those errors all over the place. And it impacts anybody that joins that CTF. So you get a bunch of people to join your CTF, modify the dates, and all those users are now impacted by these 500 errors and can't actually play in whatever CTF they were planning on playing.
That is a bit limited though, because most people can't create CTFs. So
yeah, like I said,
there is that
I feel like the rest of these issues aren't quite as interesting. Especially that one. You need to be a malicious CTF host. It's something that if somebody were to attack it, would very quickly be able to fix.
And they'd be banned.
Yeah, so maybe with a really selective use there, but I kind of understand why this one, it was initially rejected, and then they found the way to kind of affect more users that let them resubmit it and had it actually accepted. But it's
an issue. But
it's definitely an issue. One. Yeah, even without having it impacting all the other users, I think it's an issue just as a bug itself. You don't want a user to accidentally 500 themselves.
Yeah, not a good user experience.
Yeah. So the next issue is a little bit more serious. The forgot password link remained valid after changing your email. Exactly what it sounds like. I forgot password link. You should be able to effectively invalidate the forgot password links when the user state makes a significant change. So changing their password, changing their email, things like that should invalidate past password links. So in this case, though, you could do that. You can basically have a backdoor into their account even after they've changed their email. Of course, you need to compromise an account in the first place to get there. Similarly, session tokens were valid despite a password change. Again, you generally want to invalidate sessions. well, on password change, you don't want to do that just with any old state change, but password change is a big one where sessions often do get invalidated. And lastly, you see that same race condition when you have a limited number of teammates that can join a CTF team. That same race condition, you can get like 5 people in a 2-person team type of thing.
Yeah, that one was fun. That one was
yeah, I mean, it's the same as the race issue above, just a different check.
If you had to rank all the issues, which would, like, in order of, like, most interesting to least, how would you?
Most interesting?
Yeah. Probably the first one, right? On the top of the list.
Yeah, well, first and last one go there. I love the race conditions.
Yeah.
They're just always fun to be able to play around with to see. I mean, obviously, having more teammates join isn't really all that impactful.
You're probably gonna have a Discord or something, and you're gonna be sharing problems.
Yeah, like if you're going to cheat on that, you don't need to cheat by putting too many people in there. And if it's going to be for a prize or something, it's going to be obvious when they go to pay out, and it's like, hey, you know, you have way too many team members. Like, there isn't a big benefit to that one that I can see, at least. But on the interest side, like, yeah, I mean, it's just another one of the race conditions. The rest of them, though, are pretty bog standard. Like, I'd rank them pretty equally in terms of just interest.
I thought the forgot password backdoor was kind of neat, just because of how annoying that would be to a user who got compromised. Like, obviously, it does require that initial compromise, so that kind of lowers the impact. But I could see it being something that people don't really think about as a potential backdoor if they don't invalidate those links.
I don't know. I mean, that was like definitely like that's been part of like my standard test cases for a long time, is just checking validation when they invalidate certain things. Same thing for the session tokens.
See, that's fair. I don't really do much web stuff, so I guess it's just something that probably is a little bit more interesting to me than it is to you. Just where I don't have much experience in that area.
Like, but yeah, you say it would be annoying, so yeah. I can agree to that.
But like, just some really fun bugs. Unfortunately, he didn't get paid for any of them, though. He's getting merch, but you know there were no bug bounty payouts. But it's probably yeah,
it seems like a lot of the private bounties, actually, like that we see reports out of, also aren't paying too well,
which is weird. You would think private bounties would be more lucrative, you know, just by nature. But
oh no, I guess part of it though is probably just private bounty because they're not ready for prime time yet. They're not ready to have a bunch of people hitting it yet. Whereas if you've got a really mature security program and all of that, you're ready to have a lot of people hitting you. Just go for it and open it up to everybody. At least that's my thought.
Yeah, but he probably got a real kick out of you know, finding issues in the CTF platform hosting service as a, you know, CTF player and a vulnerability researcher. So that's what made it. Really
yeah, and
fun,
that's why I want to talk about this CTF, one. It's you know, attacking the CTFs. Obviously, the people writing the CTF should be thinking about security.
They have
too.
Security in mind. Yeah.
Yeah. So it is fun. Like I said, that race condition one is, I mean, it's just a naive way of writing it, so it's not uncommon. Especially once somebody's just kind of rolled their own. It is uncommon when you have more complicated scoring systems, though.
Yeah. So getting into HackerOne bounties directly, we have 3 issues in Slack. This is our first one. Which is basically their turn server allowing TCP and UDP proxying to the internal network.
Yeah, which to be clear, like turn traversal using relays around NAT. It's meant to act as an intermediary. It's meant to be a relay, so that's not all that surprising. But generally speaking, you don't want your turn server to be able to hit all of your internal IPs and just proxy requests internally, unless you've got it in like a DMZ or something and it's not actually able to hit anything important.
Yeah. So this issue is a little bit old. It was reported in April 2 years ago.
Yeah.
But it was only recently just disclosed. So
yeah, and they actually initially denied the disclosure in February.
Oh, I didn't see that.
Yeah, so February 25th, 20 days ago, they canceled the request to disclose. Because they're performing a review of high severity and above disclosures, and want to give your report appropriate consideration before it becomes public. Of course, they replied, like, I thought you guys fixed this 2 years ago. So, I mean, it might have just been a case where they didn't look at the date and just saw a new disclosure request. But I did think that was a little bit funny.
So it wasn't an outright denial, but it was more like a postponement. Like, we want to, look over it and see first. Yeah. I think that's fair. But it's essentially because the issue is the attacker can set the peer address in the XOR peer address field of turn. I'm not too familiar with turn.
Yeah, it needs to be, like I said, it is meant to be used as a proxy effectively. That's how so effectively, like, where turn comes in is, say you have, where I've seen this used, is like you've got a game console, you want to communicate with another console. But you're both kind of behind routers, firewalls, probably kind of preventing you from really directly connecting to each other. So instead, you're both connecting to the turn server. And from there, or I guess just one of you actually, would be connect to the turn server. And you just tell it, who do you want to connect to, and it'll kind of proxy your request. Proxying's part of it. So you're able to set the request that you want proxy. The issue is that you're able to specify an internal URL.
Yeah. So, kind of a straightforward issue. Our second Slack issue, though, is a little bit more interesting. It's an issue we actually talked about recently, and it's HTTP request smuggling. And I remember saying before that I found this attack to be really neat. It's not a new type of attack, like you were saying, but to me it was a new attack. So the desync attacks
are, like, I mean, it's not super new. This isn't like the first time it's being done. Like, the desync attacks are why we're seeing a lot more of these request smuggling, and this is another desync-based smuggling attack. And that is really just over the last, I want to say few years, but it might be even less time than that.
I thought this like attack strategy was known for like the past like 10 years or so, but maybe.
Well, again, it kind of comes down to like being known versus being actively looked at a lot. Like, I'm saying there's been more of an uptick in the past few years.
Yeah.
Like request smuggling is really old. That's a really old thing. This desync attack in particular, I'm actually not super confident in saying how old desync attacks in particular are.
I thought there was a white paper that might have highlighted it in like in the 2000s, but I can't say for certain. Like, I don't have the report or like the white paper or anything like up, and I might be misremembering something.
I'm trying to look into it a little bit. I've just done a quick Google here, and I see mentions in like mid 2019 of it being reborn. They have some history here.
Oh, nice. Okay.
Mentioning request smuggling 2005, which expected, and HTTP desyncs actually being a DEF CON 27 presentation.
Oh, wow. Okay. So I must have been thinking of request smuggling directly, not
and request smuggling is fairly old.
Yeah.
But the desyncs itself, or at least in particular, transfer encoding, like the chunked and content length as being the desync vector, I believe is quite recent.
Yeah. So like you were saying, that's the exact issue here. You could cause an arbitrary request hijack on slackbee.com and force victims to issue GET requests on any arbitrary domain. Due to how that backend server discrepancy.
So it would kind of forward the request. And with that, then the request is going anywhere, and it's including all of their Slack cookies. Like, it's appending. Basically, you're able to control the start of the next request. So you have it be a GET to your own domain, and it'll effectively forward it off to your domain with the entirety of whatever the rest of their request is. So including all their cookies, including their body, all of that is going to be accessible to your domain. We talk in reasonable detail about the desync attack. I want to say it was just last stream.
I think it was the last episode.
Like, I'm pretty sure it was just last episode, so you can kind of check that out. I'll actually figure out what the specific topic was, but we've covered a bit of depth already on the desync that, it was, the topic was HTTP request smuggling using malformed transfer coding header. So yeah, it should be pretty easy to find if you just look at episode 32.
Yeah. So obviously, that ability to steal session information from the cookies and whatnot is a pretty big deal in a chat application where you can leak personal or company data from a victim. So the issue was fixed very fast. It was reported and fixed within a day. This issue was not like nearly as old as the last one. The last one was 2 years old. This one's only 4 months old. So they were a lot quicker to disclose this one. But yeah, you got awarded $6,500. And I like this one just because, like I said, I like this type of attack. I think it's a very interesting and clever attack. And this one showed that it could have some huge impact and like potential ramifications as well on an application like Slack.
Yeah, and I will say, I'll just repeat something I said last episode. If you kind of want to understand this, don't read about it. Just try it out yourself. Build up a little lab with the vulnerability and just try and exploit yourself. That's the best way you're going to kind of get what you can do with this and what you can't do.
Yeah. So we can move into our last Slack issue, which is DTLS using a private key in the public domain. It seems like a fairly straightforward issue. I haven't really looked at it too much, though.
It
so
is.
I'll let you take that one away.
Basically, Slack uses the Janus WebRTC server, which does support DTLS. Basically, the key used there is the default key that comes with the Janus web server, so anybody else who downloads the Janus web server for themselves can have the private key that Slack also is using. Very straightforward issue.
That's something like that's pretty like that shouldn't be happening. Let's be honest. I don't know how that even like on something like Slack.
Oh, I mean, how it happens is pretty obvious. It's leaving the
it's
default.
Obvious, but it shouldn't be excusable. Like,
I mean, ideally,
like
Janus itself would generate a new certificate just on the initial startup.
Yeah.
That isn't to say that Slack isn't responsible. Just ideally, you have the same defaults that just generate new keys and stuff. But I don't know. I mean, I wouldn't like. I still would put blame on Slack for doing that.
Do you think it's reasonable to expect Janus to do that?
Oh,
like, do you think
it's not reasonable to expect any application to have the same defaults. You should be verifying that yourself. But I do think that applications should have same defaults. You shouldn't trust. It's, trust and verify. Or trust but verify, I guess, the statement.
Yeah, that's the old saying.
Yeah. I mean, you can... And in this case, once you verified, you'd realize, nope, can't trust them.
So we do have one last exploit that was kind of a last-minute addition. It was a DOM-based XSS.
Well, so they call it DOM-based XSS.
Ooh, we're getting spicy. We're getting a disagreement here.
It doesn't really matter, actually, to be honest.
Okay.
I feel like they call it DOM-based because they pull it up out of the hash part of the URL.
Okay.
Sorry about that. So they pulled up. I'll just pull up the code here. I initially saw this as maybe being
sensational.
No. Sorry. Let me back up. When I was commenting on the DOM aspect, it's just because whether or not this is DOM based completely depends on something else, some other part of the application. It might be DOM based, it might be server rendered. At least I assume you could use this on the server side. I mean, it's part of a React thing. Maybe this is only used in the clients, then it would be DOM based, but it seems like this is just a library that you can use generally. So I don't know. Maybe I'm mistaken about that. Either way, let's just get into it. What is this called? htmr. Basically, you give it an HTML string, it creates a React object. That's all it does. So you call the convert with something that has an XSS in it. So it takes, in their example, window.location.hash and effectively just converts that into a React object. You get a cross-site scripting with it. So
pretty interesting.
my initial run was okay, but this is a library you're calling. Is you should like the application that's calling it is the one responsible for
You should be sanitizing the internet.
That was my initial thought. Yeah, was that the application's the one responsible for this. That said, what kind of made this one a little bit more interesting is, and they reviewed this, they closed it, and they closed this as not applicable. The library isn't made to protect you against cross-site scripting. The developer is responsible. What it turns out, though, is that if you convert it into HTML entities, so you sanitize the string that you pass in, naturally, as you'd expect, it doesn't work. You don't get any excess. But if you double encode it, you do get an XSS. And that's because what the application does, what the library does, is when you have a node type that has the like text content in it, it'll grab that text content. And when it goes to set it back in, it'll take the text content and it'll pass that into the inner HTML. So if you're aware kind of with some of these DOM XSS, it always comes down to using inner HTML instead of a more secure option to set values. So you're basically, if you can get HTML into that, into some that try to set the inner HTML attribute, you're able to get cross-site scripting. So essentially, the text content value that grabs, that's going to have undergone one desanitization, I guess. It's going to have unescaped the data once because of that. So effectively, this whole thing just ends up stripping out one of the protective mechanisms, one of the layers of HTML entities.
Okay.
Basically, like what they should have been doing is just passing it in with the text content, like just setting the text content instead of grabbing text content and putting it back in with inner HTML. And they even have a comment that they're not dangerously setting inner HTML. This is okay because it's not dangerous because they used the text.
If they say it's not dangerous, it's not dangerous. I don't know.
Yeah, well, and I mean, like, it's the obvious example. It's not vulnerable to. You send it the XSS and it's fine. You send it the sanitized data and still it works as you expect it to work. It's just when you do the double encoding that causes a problem.
Okay, so it's a little bit more of a complex issue than the title would suggest.
Than the original report would suggest. Yeah. I mean, they don't make that clear at all in the original report. So I totally
after
get
that clarification, it did get fixed, even though they...
Yeah, it did get fixed.
Okay.
At least,
okay, cool.
At least as far as I know, it did get fixed. Yeah, it's been fixed in 08.7.
No bounty, though. Oh, somebody pointed that out from chat. That sucks.
No bounty, but we've seen that with a lot when we've talked about some of these JavaScript libraries. Open source libraries getting fixed. It's just part of this general, like, no third-party modules thing. So they're getting the reports, they're getting people looking at it, but not exactly good bounties from it. It's open source and not even the main project.
Yeah, so I guess that's fair. But
taking from chat, Vue is the next React. I don't know. Is it going to be Vue, or are we going to start seeing more Svelte? I mean, that's been picking up a bit.
What was the latter one you said?
Svelte, I want to say it's actually said.
I'm not into like web stuff, but I've never heard of that second one. I've heard of Vue.
Well, I use Vue on most of my stuff personally. That said, Svelte or Svelte, whatever. I've been seeing it getting used a little bit more. It's still pretty early. Like, it was just released a few years ago, whereas Vue, I guess Vue wasn't that much earlier, just a handful of years. But either way, it cuts down on the bulk of an application by acting like more of a compiler rather than just a bundler and optimizer.
There's so many JavaScript frameworks, it's hard to keep track.
Do you know what? That was true for a little while, and that's just become a meme. It just kind of comes down to, there was a time where we had an explosion of JavaScript stuff, but that was around 2010. It's been fairly stable. React has been the dominant force for quite a while. I'd have to go look up all the details, but I want to say like since 2013, it hasn't been that bad. But there were a couple years, like probably 13 and 14, we had a ton of stuff coming out. And kind of right around that turn of the last decade, there's a ton of stuff. But I mean, JavaScript, I think React, like, it's been such a consistent top player for the last while. We're starting to see a few new things coming out. It's mentioned out of chat, WebAssembly and stuff. And to answer out of chat, did you look at Dart.js or WebAssembly? I've looked at WebAssembly and ASM.js before that. We've actually talked about WebAssembly before. I think we had a topic about reverse engineering a WebAssembly application and finding like...
I think it was a game thing where they had a game wrapped in WebAssembly for obfuscation purposes only. Like, it didn't even use it for any reason other than just to make it harder to reverse. Yeah, I do remember we talked about it before, though. Yeah, I forget what episode. It was probably a few episodes back.
Yeah, it's been a little while. I haven't looked at Dart.js. I've only barely looked at Dart. I've never really used it. I've done a couple assessments with projects in Dart, but just need to kind of read the code, not write it. That said, jumping back on my little rant there, it's a lot easier now to pick up your JavaScript frameworks. It's not that much of an explosion anymore.
Yeah, so the React versus Angular wars are over? React kind of
React versus Angular is still there, but like they've been a dominant force for a good chunk of time. Vue's a bit of a newcomer, but like that's it. We're not talking about
hundreds.
We're not talking about having knockout. We're not talking about having basically just there was, like I said, I it's been a while since I've looked into all the history on that, but there was a huge explosion at one point, and it made sense to say that. It's not so much anymore, and I wouldn't be afraid to jump into some of the JavaScript stuff now.
Okay. Do we have any more on that issue, though?
No, I think I've kind of covered the bulk of it there, yeah.
Okay. So we'll move away from exploits, and we'll get into some defenses. Get back into some low-level defenses, actually. Our first one is a compiler-assisted scheduler for detecting and mitigating side channels on caches. So, on this show before, we've talked about side channel attacks quite a bit on caches, as well as the three major types of those attacks. So there's like flush and reload, where an attacker flushes the cache to force memory accesses to bring data into the cache. So the attacker can kind of time that, try to access the same memory line and see how long it takes to see if the victim also accessed that cache line. You have flush and flush, which is kind of similar, but it takes advantage of the fact that the cache flush instruction bails early if the memory line isn't in the cache. So you can kind of measure that eviction time. And then there's also prime and probe, which an attacker can create an eviction set, fill the cache lines with it, and then when the victim accesses the cache, it checks to see if those lines were evicted by looking at the access times. Just measuring access times on these different types of attacks to see if the victim also accessed the same memory. The goal of this paper is to prevent these kinds of attacks without significant performance overhead, which we do see with some of the current mitigations, is they do have some of that added performance overhead. So some of those mitigations,
if you never have a cache, you never need to have the side channel.
That's true. Yeah. But some of those mitigations include like encrypting the cache address, locking cache lines, stuff like that. But that's pretty expensive in terms of the performance you lose there. But what they propose is a compiler-guided scheduler that they call Biscuit. And what it essentially seems to do is it inserts instrumentation at entrances of loop nests to predict cache misses. And then that information gets fed to the scheduler, which makes sure the combined cache footprint doesn't exceed the max of the last level cache. So the scheduler checks the predicted number of cache misses against how many there actually were to detect if there's like something malicious going on, and then it tries to isolate the attacker so that it can't pull off the side channel. So it basically uses the fact that cache-based side channels result in higher cache miscounts than normal program execution, so it uses that discrepancy to try to detect them. So their main goal here was the low performance overhead. So talking about the performance results, they have like a nice little page dedicated to that on page 10. And they have the timing differences between the completely fair scheduler, which they note as CFS, and their modified biscuit scheduler. They compare it against OpenSSL operations, AES, RSA, ECDSA, and they also have other charts just below it of other algorithms. And these are both timed under the no attack scenario assumption. So nobody's trying to perform a side channel during these measurements. And while the crypto ones are high, you can notice like in the graphs, the ones with the OpenSSL attacks, or rather OpenSSL, the difference is quite high between theirs and the completely fair scheduler. It's quite a bit higher. But crypto is also a lot more intensive, so I think that's understandable. Overall, they found an overhead of only up to like 6% in some of the higher intensity scenarios in when there's no side channel attack happening. And that
and I will just jump in really quickly that I think part of the issue when you're looking at the crypto ones is if you look at the time there, like at the ECSDA, the bottom time point is 128 seconds, and the maximum one is 133. When you're dealing with over 100 seconds, like a 2% difference is 2 seconds at that. So that kind of explains. Like it looks, I think, a lot worse than it is.
Yeah, that's a good point. So, like overall, they found it to be only on average like up to 6%. In high intensity scenarios, compared to existing techniques like SMT solvers, which I feel like we might have covered in the past, but I'm not 100% certain on that.
Well, SMT solver, like that's just a general technique. Well, not necessarily for the caching. Like that's just like program correctness and stuff.
Yeah, but they mentioned that that can have up to like a 225% overhead with an average of 50%. And they also mentioned a lot of existing techniques have higher false positive or false negative rates. One they mentioned, like spy detector, was 0.83 F. Theirs they mentioned at like 0.92. So it's only like, I think, 8% failure rate when testing for false positives and stuff like that. So overall, it seems like they accomplished what they set out to do. I do wonder, though, like, even though they have some promising results here with the low overhead and preventing the side channel attacks, I do wonder if we'll see a lot of adoption. Just because, honestly, I don't know if a lot of people really care about these kinds of attacks because they require such a high degree of access already to do. And if you're confident in your system security or you don't think it's an issue, 6% overhead, while small, still may be too high for people to want to consider. So, it's cool that it set out what it's, tried to do, but I still don't know if it'll really lead to much adoption.
Yeah, I kind of agree with you on that. I'm not sure we'll see too much adoption of it. One is that 6% is still, like, I'd want to see it even less. Because, I mean, part of it's also just some things are going to be run on smaller, more embedded systems that just don't have the power or are otherwise constrained, where 6% can be significant. That said, like, I mean, it's not a lot. Like, I'm not trying to bash as being, 6% is just so high, because it's really not. Most areas are going to be to deal with having that little bit of extra, but I do agree. The people that are concerned about this, it's definitely a smaller subset than those that just use OpenSSL in general.
The thing is, too, is having to use their own custom scheduler, while it's cool and it solves the issue, I think that will be a deal breaker for some people. It's obviously not a high performance scheduler because it has that added overhead, even if it is only up to 6%. So it kind of limits the options of the person who would want to use this. Because the scheduler is something that, it is one of those critical system pieces that can really cause cascading issues. So people are, I think, less open to messing with it. So I think that is another consideration.
Yeah,
That being
I'd
said,
agree.
I think it's still cool that they managed to do it. They managed to do what they set out to do, and it's kind of cool in how it works. So we still wanted to cover it, but I just do question how adaptable it's going to be. But yeah, I don't really have any other thoughts on that. The next paper, though, I think is quite a bit cooler than this one. It's bypassing memory safety mechanisms through speculative control flow hijacks. So this last paper we have tunnels in on memory safety issues, and mitigations that try to minimize their impact. So, some of these mitigations that are pretty common nowadays, maybe not as common, but there's control flow integrity that you see in Windows. You have stack canaries for preventing stack overflow, trying to mitigate stack overflows. And, you have memory safety mechanisms that are built into languages. So, memory safety checks. So if you go to, index an array in Golang, for example, and I'm using Golang because that's actually a language they target here. If you try to do that, it's going to check at runtime to make sure that index is actually safe and not out of bounds. So, they have a mechanism that the compiler puts in to check for that. And what they basically talk about is trying to use speculative control flow attacks to bypass those added safety measures. So they focus on Golang's runtime memory safety checks, GCC's vtable verification, and the smashing stack protector, or SSP. And the way they pull it off is by abusing speculative execution. So you basically cause the predictor to speculate incorrectly if a bounds check will pass or not, and that can cause a buffer overflow due to it speculating incorrectly. It's not surprising that all the things except for CFI were vulnerable. They couldn't hit CFI. In theory, CFI is vulnerable, but I'll get into that in a minute. But in reality, anything with a check can be hit with a low level, or at the low level like this. So for example, like stack cookies, they mentioned the attacker can basically overwrite the return address, and then the attacker forces a misprediction so that the return address is transiently followed and executed. So it's not really a new attack. It's something that we've already kind of known about. It's just demonstrating how these known attacks can be used to hit existing mitigations that are in place.
Yeah, it's fun to see it kind of being pulled into the practical. They're doing something with it.
Yeah, exactly. The only one that they found they couldn't really hit was CFI. They found the window was too short for them to hit it. I thought that was kind of interesting. I wonder if that is like by design, like if they implemented CFI with potential speculative execution in mind while doing it.
Probably not, but CFI at the performance level, I think, just has a bit more of a limiting factor to it. Because it is being done kind of in line with all of your like indirect jumps and everything, whereas they maybe weren't as concerned when dealing with like your return addresses. Like obviously they still care about it at that level, but I could see it being just more related to the situation.
Yeah. So they propose some mitigations for these types of attacks, which is probably the more interesting part of the paper for like, the maintainers of like Golang, for example. And it's basically load fences. For stack protectors, they suggest putting a fence around the canary loads or masking the return value and setting the mask to 0 in failure cases. For Golang, they propose, again, adding a fence after the compare instruction in the is-in-bounds operation, which is used on array checks. Or like stack protectors, introducing a masking sequence to ensure the index is safe. I think they said that the Golang devs are actually considering implementing some of their mitigations, which is pretty cool. So overall, like thoughts on the paper, it's a cool paper. The mitigations, though, are obviously very targeted. It only really patches a few of the known vectors, like common operations that are vulnerable to it. There's likely more, that aren't covered in this paper that wouldn't be protected against with these types of mitigations they propose. Because you can't really just start throwing load fences everywhere. They have quite a high performance overhead. So you want to
isn't
find
the
those
suggested
areas
mitigation for the LVI, wasn't that tossing load fences everywhere? Isn't that what they suggested?
Might have been, yeah.
So
like load fences are like the only way really that it seems you can prevent these types of attacks. But you want to be careful with how you use them just because of that.
Yeah, I'm not saying it's a practical thing. I'm just saying I think they suggested in that paper pretty heavy use of load fencing.
Yeah, this paper is kind of similar to that one in many ways. It's cool that they left in that CFI didn't work. I think with white papers, you'll see fairly often that failed results are probably chopped out. Like you only really see the positive findings, like, oh, we hypothesized this would happen, and hey, it did happen. You don't really see the ones that they hypothesized would happen but didn't work out. So I think it's cool that they kind of included that. It's interesting how CFI was the only one that gave them problems, really. But I think it's cool that they kept it in there. I think they deserve a bit of props for it. But yeah, that's pretty much all my thoughts on the paper. I don't know if you have any additional thoughts you want to add in.
No, I don't.
Add in there. No? Okay. So we'll wrap up the show here. That pretty much concludes all of our topics. Thank you to everyone who tuned in. We are going to have another video coming out within the next day or two of some cool security-related stuff you can do if you're one of the people stuck at home due to this coronavirus craziness. So, keep a lookout for that. You can catch the VODs on Twitch or on YouTube 24 hours after the stream. Twitch immediately, YouTube or any of our other platforms 24 hours. We also have the previous podcasts up on Spotify, Apple Podcasts, Google Podcasts, and we have them on a few other places as well that you can check out on Anchor. And if you want to, get involved in our community a little bit, you can join our Discord or follow us on Twitter. But yeah, that pretty much sums up the episode. We'll be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific. Just looking at the chat. I'm one of those who will still show up at work. Oh, that's unfortunate. Yeah, not everyone's able to work from home, unfortunately. But, for the people who are, we'll have a little video of some stuff you can do while that's happening.
Yeah, it's just a few ideas if you're looking to fill your time as you're lonely here again and maybe want to learn some
while
more
the virus
exploit
ruins
dev.
your life. Yeah. But yeah, we'll be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific, and we'll see you guys then.
Thanks for watching.